how we could get the baseline for saying that, okay, I now have find a model. So this is a trained model or hypothesis, trained model, and it predicts the label, like the future positions of the players. And it has some error. Let's say y hat minus the true label is squared is 0.1. How do we know if this value is good or bad? Where can we get a baseline from? Any comments from the audience?
Wouldn't it depend on the assumptions on your error distribution?
Yeah, so I heard already some trigger words, distribution. So that's one of the cool things you can do with probability theory. You can not only torture students with probability theory, but you can get baselines. So if you have a joint distribution of features and labels, then you can evaluate using basic calculations the posterior distribution of the label given the features. And this distribution might look like this. So it concentrates around some value. Let's call it y0, and it has a variation. So typically, in general, this distribution will not be perfectly localized. So for the same feature values, we have different possible labels. And this is related, when you look at data, this is related to the fact that when you look at the scatter plot of the data, so you have some data points, then you have features of data points and labels. And when you do a cross-section for a given feature value, then you typically have a spread here of data points that have very similar feature values, but different labels. And this width in the vertical direction corresponds to this posterior variance. And this variance is one way, or is one possible baseline. So if you come up with a probability distribution for features and label, then you can plug it into some scientific computing framework that can do this conditional distributions and read out the variance. And if the variance that you get out from here is, let's say, 0.1, then you know, okay, you are almost on the same level as the best method you can think of. And the best method you can think of uses the posterior distribution. There's no better way to do it. If you assume, if you subscribe to the probabilistic model. So if the data points are, for example, IID draws or realizations from this distribution, then the best you can do is this posterior variance. So this would be one way to get a baseline. Sounds good?
Yeah. So would I should I like create some kind of like a specific statistical model, this is just and then I can use that.
That's the problem. That's the problem. I mean, it's this whiteboard here is very patient. I can draw all these beautiful formulas and can write down these beautiful posterior distributions. But how do you get this probability distribution? Who tells you this?
Right.
For a game.
Right.
So one way to do it would be to collect many data points and fit a probabilistic model using maximum likelihood estimation.